The objectives of this video is to work out bending moment, shear force, and axial force diagrams. Okay, so on the left hand side of this structure we have a roller, and a roller has one vertical restraint, as you can see over here. On the right hand side of the structure we have a fixed support, and a fixed support has a vertical, horizontal, and twisting and rotational restraint. So we have three reaction forces here. 10 kilonewtons. We have 10 kilonewtons pushing upwards 1.5 meters away from the fixed supports, and a clockwise 30 kilonewton meters moment 1.5 meters away from the roller. As you can see, in the middle of a structure we have a hinge. Now what is a hinge? A hinge is a point in a structure which is free to rotate. So there's no moment about that point because there's no moment restraint, so it's free to rotate. So the sum of moments about a hinge is always equal to 0. Okay? So that's what a hinge is. Make sure you just remember that. So first of all we have to establish equilibrium after we've drawn in our free body diagram, as you can see, to work out our reaction forces. So initially we do sum of forces in the horizontal has to equal to 0. So sum of forces in the x direction equals 0. Since HB is the only horizontal reaction force, it equals to 0 kilonewtons. It has nothing to react to. Secondly, we do sum of forces in the vertical direction equals to 0. So we have VA plus VB, which are our reaction forces here. VA plus VB plus 10, Y plus 10, as you can see here, because we have a point load pointing upwards, and this all equals to 0. Rearranging, we find that VA plus VB is equal to minus 10 kilonewtons. Okay, so now that we have one equation and two unknowns, we have to take advantage of moment equations to work out the following reaction forces. Okay, so we can a couple of hinge rules. Okay, hinges. Moments from either side of the structure about a hinge is equal to 0. What do I mean by this? For example, if we take out the left hand portion from the hinge, so from the hinge out to the roller, if we just draw that, we can use this to work out the moments. Okay, or we can cut out the left hand portion and use the right hand portion, which is out from the roller to the fixed supports, and we can do moment about the hinge to equal 0, and we can work out unknowns on this side. Okay, or the second rule is the total moments about a hinge is equal to 0. So this is a normal rule that could be applied to every structure. Sum of moments about a point is equal to 0. So this is the same thing. But the main one to understand is that moments from either sides of the structure about a hinge is equal to 0. And as I've shown you here, if, like for example, if you go out from the hinge to the roller, so you cut out this portion here and draw out this bit here, you can do moments about the hinge is equal to 0 to work out the reaction force VA. Or you can cut out this left hand portion and use the right hand portion to work out HB, VB, and moment, for example. Okay, so I'm gonna cut the right hand side out and consider this side over here. Okay, this side over here. So we do sum of moments about the hinge. The left hand side is equal to 0. So we have minus VA times 3. What's minus VA times 3? So this is the reaction force over here. It's causing a clockwise moment, so it's negative, and it has a lever arm of 3 away from the hinge. Okay, and remember, we're only considering the left hand side from the hinge. Okay, then we have minus 30. Why is minus 30? Because we have a clockwise moment of minus 30. This is all equal to 0. Okay, so rearranging this, we find that VA is equal to minus 10 kilonewtons. Okay, now that we already have the equation that VA plus VB is equal to minus 10, okay, we can substitute the value of VA in this equation, and we find that VB is equal to 0 kilonewtons. Now that we've established the equilibrium, our free body diagram, and our reaction forces, we can do our cuts and work out everything. Okay, also, but before I move on, we can also do moments about the hinge from the right hand side, which equals to 0, because we have to work out this moment reaction force. We can do M. So if we cut out the left hand portion, which we already considered, we have M, which is this one, and we do moments about the hinge, of course, plus 10 times Now what is 10? 10 is the reaction force VB that we found, times 1.5. This is the lever arm towards the, actually this should be plus 10 times, sorry, it's right, sorry, excuse me. So we have moment over here, which is the anti-clockwise moment, plus 10, which is the point load which points up, and it has a lever arm of 1.5 meters away, and this all equals to 0. So we find that our moment is actually minus 15 kilonewton meters. Now the reason why I didn't include VB is because VB was 0 kilonewtons, so this is no force over here. Okay, so we find that the moment is minus 15 kilonewton meters on this side. So far we've established our reaction forces. So VA is minus 10 kilonewtons, VB is 0 kilonewtons, our moment over here is minus 15 kilonewton meters, and our horizontal force over here is 0 kilonewtons. So now we can do cut 1, cutting from the left. Cut 1 includes from the roller out to just before the clockwise moment, and the interval is from 0 to 1.5 meters. So the extremities are from 0 to 1.5. We draw in the cut. Now we have this reaction force was negative 10, so it's drawn as 10, but it's pointing downwards. So that's what negative 10 is. Okay. So the whole cut is a function of x. This is our sign convention over here. Shear force is pointing down. Moment is a anti-clockwise one, and n, the axial force, is pointing out to the right. So we do sum of forces about the x is equal to 0. So n is the only horizontal force, so it has nothing to resist. N is equal to 0 kilonewtons. Secondly, we have sum of forces about the y direction equals to 0. So we have minus v, because the shear force is pointing down, minus 10, because this is pointing down as well, is equal to 0. So we have v is equal to minus 10 kilonewtons. We have a shear force of negative 10 kilonewtons in cut 1. Now that we've worked out our axial force and our shear force, we can work out the moment. So we can do moments about point B over here, which is just at the internal actions. Okay. So we have m, which is this anti-clockwise moment, plus 10 times x, because this 10 over here is causing an anti-clockwise moment about point B, so it's positive, and the lever arm is x. So m plus 10 times x is equal to 0, and this gives us m equals minus 10x. So you can see the moment is a function of x, so it's going to be a linear line. So we need to substitute our extremities, 0 and 1.5. So when x is equal to 0, m is 0 kilonewton meters, and when x is equal to 1.5, m is equal to minus 15 kilonewton meters. Now due to time limits, I'll continue the example in the next video. Thank you.